Hi, I talked previously about working towards a few robot projects and wanting to use MicroROS and ROS2. The system I'm building will need real-time operating systems on the Raspberry Pi Pico too, so I'm working on patterns to integrate MicroROS and FreeRTOS tasks. Last time I focused on publishing messages from the Pico. This time I want to add some subscriptions and taking some actions based on the subscribed messages. For this video, I'm going to return to my video turntable project, a really simple robot because it's just got the one joint. On a previous video, I built a video turntable because it's more interesting to see PCBs, breadboards and etc. rotating a bit rather than just still shots. Still shots are boring. And on the last video, I showed how I could model that in ROS2 because a video turntable is just a really simple robot with a single 360 rotating joint. So using that URDF model, we can extend that a little bit and the activity of that in this video. So last time I sent joint angles from my Pico to visualize on the turntable within ROS2. So that's joint state message, and we're able to publish that successfully even using FreeRTOS. This time I'm going to add the listening side as well. So we're going to listen to two messages. We're going to listen to a command velocity, which is a twist message, which I'm going to look at the Z rotation angle velocity to drive how fast the turntable and indeed what direction the turntable is moving in. And then we've got a do pose, which is going to be a PoseStamp message, and that's going to provide us with a target position we want the turntable to move to and to reach at a specific time in the future. Just like last time, the structure is the same. So we've got this pub/sub task sitting on our Pico inside FreeRTOS. That's communicating then with the world of MicroROS via my MicroROS task. That goes over USB to my ROS2 host, which is a Raspberry Pi, and that's got the MicroROS agent on it, and then off into the other ROS2 world for my RViz visualization of the URDF to see what the actual turntable is doing. So my setup, as I explained last time, is a little more complicated. So I've actually got my Pico connected to my a Raspberry Pi, which is running ROS2 and the MicroROS agent via USB. And then they happen to be on the same network as a VM, which is running Ubuntu, where I'm running that visualization. The reason I'm doing that is just that VM's a lot more powerful than my Pi, and I can get work done a little bit quicker. Let's drill into the architecture of this application and how this is all working. So we've looked already at this. Let's drill into that Pico side. So just like last time, we've just got the tasks running on here, or two tasks that I'm really worried about. There are other tasks. There's a boot task in the background to set everything up, etc. But these are really the two tasks that we really want to worry about. We've got our MicroROS bridge, which is just an extension of what we had previously. And we've got our pub/sub task, which is actually going to be doing the work. It's simulating what would be happening on the physical hardware of our robot, and it's responding to messages that it receives and subscribes to, and it's publishing out the position. So last time we had this create entities and destroy entities capability that's running inside the MicroROS bridges thread, but it's actually a request into my publish task. We're going to use that and extend that so that we can actually add subscribers. So when we create an entity or destroy the entities, one of those entity types is a subscriber, and on this in this application we're subscribing to two additional messages, that command velocity and that do pose. So we've got publishing going on all the time from our publish task, and they're calling over to a method on the MicroROS bridge. And I explained last time how we're going to queue those so that we guarantee that our MicroROS services are only called sequentially from a single thread. So we've got a queue there, and then the task within the MicroROS bridge object is what's actually going to publish them, and then it puts a notification back to the publisher task that it's completed that. We're going to use a similar pattern for subscribe. So we're going to run the subscribe and paste that up as a part of the create entities. But when a message turns up, we're going to get a handle message request over from the MicroROS bridge. That's actually going to be running in the MicroROS bridge's task. So we need to again drop that into a queue within the publisher task, or publisher and subscriber task now. And then we've got our own task here within that publisher side, which is actually going to take the subscriber items off of the queue and process them. So it will take the command velocity requests or the pose requests off of that queue and work out what it's actually going to do about them. All the code for this is, of course, on GitHub. That includes the MicroROS workspace with all the URDF, and it includes the firmware application for you to build to load onto a Pico. So over here in Visual Studio, the project structure is the same as on the previous video. We've got a MicroROS workspace within our build, which is just really defining the URDF of that little turntable robot. There it is. And it's got a script there to run up the RViz and the settings for RViz so that we can just visualize what our robot is doing. We've then got our firmware, which is the source, port, and library folder and these make files. And that's all of the project that we're building to put onto our Pico. I've got one other additional this time. I've got a little script in here called publish, which is a Python script, which I'm using to send over the pose messages. I couldn't get poses to, or set up a pose to be in the future using the command line tools very easily for ROS2. So I ended up having to script that in Python, which is okay. I'll talk about that in a bit. It probably should be in the ROS workspace, and it's not. Sorry. Because I'm using standard messages, it's fine out here and it all works, but not best practice. Yes, I know. The MicroROS bridge isn't really significantly changed from last time. So the interface into that is absolutely identical to what it was. The subscriber additions we've added in are actually being hidden behind the scenes because they're all really going underneath the create entities and destroy entities bit. There is a little bit of a fix in this from last time because I didn't realize when I was constructing the executor only needs to take account of subscribers and timers. It doesn't need to take account of publishers, and I'd added in publishers in there. So fix that bit of code there. But apart from that, MicroROS bridge is just the same as last time. Really our work we're going to do is linking out of the create and destroy entities piece. Our interface into the MicroROS bridge is really about this MicroROS entities, which is responsible for, the setup of all of those, the publishers and subscribers, and handling it. There are some additions in here that we require in order to handle the subscribers. So I have added in to here the ability to build a context for a subscriber because I need a local context to make the callback method work. Remember, we've only got the C binding to MicroROS, and so it is true C functions. So when I'm doing a callback and asking it to call back when a message arrives, I'm going to have to give it a static member function here to do subscription callback. That's going to get a context. So I also need to build a context, which is basically going to have a reference to this object, and I'm going to use that then to call the local handle subscription message. Still passing that context, because one of the things we want to know is which message have we actually got and what is the type of that message. That's just a pointer to a chunk of memory, so it could be anything. So how do we tell? Well, that context gives us a clue of what message type we're going to get back. So there's a little bit of fairly common code that I use all the time around how callbacks work in here, where we're actually using that context. We're recasting that context into a MicroROS subcontext object type, and we're using that to then find my my subhandle, which is basically my MicroROS entities, and actually call the handle subscription message on that. So just a little bit of magic there, and a helper function here to build that context for us, so it's all set up nicely. Our work when we actually inherit from this abstract class and build our new publisher and subscriber is all going to be really on this method down here to handle the subscription message. So this is what we'll get when the message is actually start pouring in, and we will need to work out what type of message it is using the context and take some action. Unlike publishers, subscribers also need to be added into the executor, and so there is an additional interface function that we're going to need in here around add to executor. I'd like to have done that within the create entities step, but actually the executor can't exist at that point until we've done a few other bits, so I ended up actually having to put in an additional function here. So all our work for this specific example is going to be in our pub entities application, and that's going to be a task that is going to run within FreeRTOS because it inherits from agent class for me, and it's going to be this MicroROS entities capability, just like it was last time. It is now publish and subscribe. Sorry, I've not renamed it. It's still my publish entities. I've just extended it. So our work is going to be adding in within the create entities and destroy entities are subscribers for the two messages we're going to receive, the command velocity and the do pose message. So we also have to add in this add to execute method. So when the subscribers are set up and the executor is ready, we can then add in subscribers to the executor so that a callback mechanism on a message arriving works for us. The messages themselves are going to come in through this handle subscription message, which has got a pointer to a message, a chunk of memory. We don't really know actually what type of message that is, so we're going to use this context here that we've got to understand that. Context is this structure that I've created over in the MicroROS entities, actually that structure, and it's basically got in it the pointer to our MicroROS entities object, so we know to actually call the subscribers and any local context data that we want to actually hold within that callback. Generally, because I'm in an object, I don't mind because I'm going to end up in the right place anyway. And we've got to have a reference to each one of these. So we will create a context and we will store them as part of our object for the publish entities, because I want to do some comparison to say, actually, is this a pose message? Because I can recognize it by context, or is it the twist message? And I can again recognize that by context. So that's what we're actually going to do. So if we have a look into the publish entities.cpp file, that is going to be very similar to what we've seen before. I'm just really adding in this capability of setting up our new publish and subscribe. So let's have a look and find them. Here we go. So we are, in addition to our publishers, we've now got a twist subscriber for command velocity and a pose or stamped pose, timestamp pose, or do pose, and we're adding those in as subscriptions. We have to, of course, delete them because we're on the destroy method, so they're finalized there. And then in the add to executor, we're adding into the executor and giving it those subscribe and actions. I could possibly abstract this out and put this into the MicroROS entities capability. I might do that to make this a little bit easier in a future version. But at the moment, I'm basically just calling the standard MicroROS C binding interface to add things into the subscriptor, or add things into the executor, and giving it the message types, etc. Our callback function, which is that generic static function within MicroROS entities, and our context. And we're doing that for both the twist message and for the pose message. And then when we get to handling our message turning up, well, we're just using that context to identify, is it a twist message or is it a pose message? So if it's a twist message, what I'm actually doing is going to just cast it to that twist message type so I can play with it. I set up a local command structure, which I'm then going to place into a queue. And the reason I'm doing that is I'm running at this point within the MicroROS bridges task, and I want to get off of that task as fast as possible and out of that and place it into code that will actually run within my publisher entities tasks. So I'm going through that queue mechanism, getting stuff out of a message into my local application structure, storing it into a queue, and then my own run loop can pick that up. And the same pretty much for pose. Doing a little bit of maths here because I chose to reuse pose with timestamp because it was nice and easy, but pose is in quadriennial. Oh, I can't pronounce that. It's in the quad format, so you've got rotations on X, Y, Z, and a W value as well. And it needs a bit of a calculation to get that back to what is actually just the pure rotation on A. So that's all I'm doing there, to just unpack that before I actually send that off. Again, a little bit more structure in the command that we're going to queue, because we're going to say it's a table pose request. We're going to give it an angle, but I'm also going to give it a time at which it should have achieved that angle by. So apart from those minimal changes, everything else on this is in the run method. Now the run method actually has quite a lot of the calculations on maths around the angles, how we're comparing angles, have we actually gone past or we are likely to go past our target angle, etc. That stuff took me an awful lot more time to do than just interfacing with MicroROS and using pretty standard FreeRTOS patterns. So I'm not going to talk about my inability to understand GCSE maths and how much time it took me to work out modulus on radians. So really the additions in here are, we're just going to do a bit of queue management. So we're going to check to see if we've got a command on a queue. If we have, that command's a table speed, then we'll change the speed. If that command is a table pose, then we'll do quite a lot of magic in order to work out what the speed and target position is. And that's it. That nicely runs now within the publish entities task and using the magic of queues. So on my demo environment, I've got my firmware on that Pico, and it's connecting via USB over into a Raspberry Pi, which is running ROS2, and it's got the MicroROS agent on there to receive messages from the Pico. And then that happens to be on the same bit of network as a virtual machine, which is where I'm actually running my RViz and visualizing the robot. I'm going to launch the RViz simulation of my robot using the ROS2 launch display only function there within my video turntable. Obviously you need to source the environment. In fact, from the code that I've put in GitHub, you also need to do curl build to actually build that environment up. It'll take a few seconds just to give you your local ROS2 environment and then be able to launch up and run that visualization. Then to actually send a twist message, I'm going to use just the ROS2 topic pub utility to publish that command velocity out there. And I can set that here to do a rotation of 0.5 radians per second, which is a reasonable lick of rotation clockwise. And if I make that negative, I can then actually rotate counterclockwise. Let's quickly look at that. So here we can see my little demo and we've got my turntable there sitting there. If I now issue that ROS2 topic pub command, and we're going to rotate it slowly forward, we can do that here. And off it goes rotating. And if I listen to that echo that topic, I can actually see that being published and see the result of it. Now, of course, I can change that and make it negative, in which case we're going to go the other way around. We're going to go counterclockwise. And we could speed it up as well. And let's have a really fast moving turntable. So I couldn't find a way of using ROS topic pub to publish the PoseStamp and place the timestamp as a time in the future. I can get the timestamp to be manually set to a specific number. I could also get that timestamp to be now. But what I wanted to do was to be able to push that to some time in the actual future. And I couldn't do that. So I ended up having to write a little bit of Python. So this is a really generic and simple little bit of Python application, which is just going to run up against the Python binding to ROS2, and it's going to set up a pub node, which is going to publish my PoseStamp message to the do pose time. And I'm doing a little bit of quad to Union calculations here just to switch the algorithm around in order that we can publish and populate that the angle I want. So all this really is doing is every 10 seconds it's going to send out a angle and new time to achieve that angle by to the table. And the time it's going to send out each time is going to actually be 5 seconds away from now. So what we should see is the table moving, taking 5 seconds to get to the next angle and then stopping. And the angles themselves I'm going to go through this setup here. So I'm just turning 90 degrees at a time, and I'm going to go around clockwise 90 degrees in 90 degree sections until I've got all the way around 360 degrees. And I'm going to start going backwards and keep doing that forever. But at least it gives a nice little demo of actually what this is doing and how that nice little pose message is really working for us. So using the pose stamped message on that do pose and that Python script to send them, I can now actually have my turntable keep going through those 90 degree rotations. So again, it's taking 5 seconds to do a 90 degree rotation. It's then going to wait for another 5 seconds before it will do the next one. So we can see that moving way through that now. It was a shame I couldn't get this to work through the ROS2 pub command utility and work out a way of actually adding mass in there. From some of the stuff I've read online, I think that might actually be possible. I just haven't worked out how and what the magic spell is to actually get that to work. If anyone does know what that is and how you would do that, please do let me know. I'd be really interested, and I expect a few other people watching the video would be interesting too. So some more success here. I have MicroROS and FreeRTOS working together in a simple project. I can publish and subscribe, which means I can do some useful project work. Though I have more work to do, as you can see from my skill card. Right now, I think I have enough to build my actual video turntable robot Mark II. Stay tuned for that one. Thank you very much for watching. Please do like the video as it helps other people find it. Please subscribe if you haven't already and hit that notification button to get notified about more videos from me. Goodbye for now.